Hello everyone, a very warm welcome to this video. So far we've seen the basics of Mapreduce, we've seen the advanced topics, but what if instead of a traditional key value pair, if we want to pass our own objects, or what if all the data is not text but has no delimiters, let's just say. So in this video we are going to explore those territories where let's just say that everything does not adhere to the /n ending. So can we have our own data format and can we have our own key value pairs instead of using the standard int writable and double writable stuff? So let's get going.
In this video, we are going to talk about the advanced concepts of Mapreduce. So we've already seen first part of advanced topics, and in this video, we'll take that discussion further. So let's see what we are going to cover in this particular video. We'll start this discussion by talking about we'll then talk about sequence files, Avro. We'll talk about compression options and input formats. So let's talk about it one by one. Let's first start with data types. Now, while looking at the word count program, one thing was very clear that normally Java would have stuff like integer, string, float, but strange, Mapreduce had int writable, text, float writable. So why is it so? That's the first question. So question 1 to be answered is, and the second question is, what if instead of using these types like integer and text and float writable, can we do that? So these are the two questions that we need to answer. So let's get started. So let's first answer question number 1. Now, normal Java has types which are but this structure does not fit for Mapreduce. Let's understand why. In Mapreduce, data has to be passed across the network during the shuffle and sort. That is why data has to be serialized. So int or int writable is nothing but int that is and the interface used for the same is Writable. So all the keys and values in Mapreduce program needs to implement Writable. That's the first important point. The second important point is the keys, once they reach the reducer phase, they should be sorted. That's why we should also implement comparable. So an important point here is all keys and values in Mapreduce should implement Writable. Should implement comparable. So the way hierarchy looks like is so from Writable there is another interface that's derived called as Writable comparable, and from there we have the concrete implementation which is Writable. This is how the entire hierarchy works. An important note here is though the data types are named as int Writable, they actually implement both Writable and comparable. That's the idea. So that is why instead of int in Mapreduce we use int Writable, instead of float we use float Writable, instead of double we use double Writable, instead of string we use text. That's Writable comparable basically. This is how the data types work in Hadoop. This is how the data types work in Hadoop. Now that comes to, or that brings us to the second question that we had in the beginning of this section. So looks like Writable comparable is clear, but what if we want to pass our object? So instead of integer or float, let's say we have our own object called as date. We have our own object called as date. how do we pass that from the mapper to the reducer? So what we'll have to do is we'll have to create a new class called as dateWritable, and because it implements writable comparable, we will have to give implementation for 5 methods. Read fields for deserialization, write for serialization, equals and compare to. So we'll have to give implementation for read fields and write. That will be basically for the writable part. So this could be, or date could be serialized as well as deserialized, and equals hashcode and compare to for the comparison part, because we are implementing comparable. So once we give implementation of this in our Mapreduce code, in the driver class, we can define that as dateWritable. In our mapper, we can always pass dateWritable as key or value, and reducer we can receive it. So the point is, we can implement our own data types, and if we choose to do it, we will have to first create a class, let's say in this case dateWritable, and we'll have to implement writable comparable. Because we are implementing writable, we'll have to give implementation for read fields and write. Because we are implementing comparable, we should give implementation for equals, hashcode, and compare to. So now let's quickly reiterate this whole thing and put things in perspective. So we'll put class dateWritable implements writable comparable. So this will in compare to, we'll say so if year is equal, then we'll compare the month, and if month is equal, then we compare and based on that we will decide the equality. Then in our driver we will specify that and now this value will be parsed as a date. This value will be parsed as a date. That is how you can implement your own format. That is how you can implement your own format. So quick notes here. Int and int double etc are primitive data types. Hence, all the key value pairs are supposed to implement writable. This interface takes care of serialization. That's the idea. So that is how data types and custom writables work. So the next topic we will discuss sequence files, Avro and compression options. So these three go hand to hand. So let's understand them together. So this is the entire concept of data types and custom writables. Now let's talk about sequence files, Avro and compression options. Mapreduce can work with text files. But an optimal strategy will be So an optimal strategy would be to serialize the files and save space and processing time. So the default serialized files are also referred as sequence files. So in a nutshell, sequence files are files that are so basically when you get text files, you are free to convert them to sequence files. That's the default format that you can convert to, and that will help you save processing time and space. That is called as sequence files. But sequence files comes with a major limitation, and the limitation is that so let's say when you get data which is in text, you convert them to sequence files, you process them in Mapreduce, perfectly great. But now if you want to give that to some other team for, let's say, processing in .NET, that won't work for you. Why? Because sequence files won't be processed in other languages or frameworks. That was the biggest limitation. So sequence files are a way to serialize data. They come with a major limitation that they are to solve this problem of being very native to Java and Mapreduce, a new format was created, and the new format is called as Avro. Avro is a serialization format that is global in nature. When we say global in nature, you can perfectly process Avro files in Hadoop as well as other languages. So it is fairly global in nature. So quick recap. And on top of it, or Avro, so sequence is default in native. You don't want to do that. So you can use Avro, which is a serialization format that is slightly global in nature. Now, once you are converting or serializing the files, you also have option to compress them. You can use gzip, but gzip has a limitation that you cannot split the files. That means if you compress something with gzip, only one mapper can run to process that entire file, which is something that we don't want. So we can choose to compress. The file which we are doing it in serializing using sequence or Avro in another codec like Snappy or LZO. Snappy is one of the most popular compression frameworks or codecs that are being used right now. So in a nutshell, serialization or sequence files, Avro and compression are basically techniques that will help you get that extra performance. You get data in text. The industry standard is typically you will convert them to Avro, serialize them using Avro, and you will use a compression codec called Snappy. So your incoming data which is in text would be converted to an Avro file and compressed with Snappy, and then you will run your programs to get that extra bit of performance. That's the entire idea of serialization with Avro and compression. So a quick is the native So that is all about sequence files, Avro and compression. So far what we've seen is integer, double, etc. are primitive data types, which is not going to work for us in Hadoop, because what we want is data to be transported across the network, and that is why serialization is must. That's why all the keys and values they implement writable, and all the keys they implement comparable, because they are supposed to be sorted. So that is first dimension of advanced part of Mapreduce, where we can implement, or we can have our own objects which will implement writable, comparable, and give implementation for 5 methods: read fields, write, equals, hash code, and compare to. Other advanced part is we can compress data. Snappy and LZO are the most commonly used compression codecs. Once data is in, which is in text format, we can choose to serialize it. For serialization, sequence files and Avro are the choice. Avro is more popular because sequence file is more native in nature. The third and the last topic in this advanced series of Mapreduce is input formats. Let's understand input formats now. The first question that would typically cross your mind is that the default block size for Hdfs block is 128 MB. So let's say we have a file which is, and the file happens to be 200 MB. Or let's say happens to be 300 MB. What 300 MB means: 128 plus 128 plus 44 MB. 128, 128 and 44 MB. These will be the three blocks. Now the way our data would look like be something like now. Let's say this is 300 MB data. Now there is no guarantee that every 128 MB will be a logical end. So that means the first 128 MB can end somewhere here. The next 128 MB can end somewhere here. So how does this really work? So let's understand this with some explanation. By default, by default Mapreduce uses text input format. Let's understand what exactly is text input format. The byte offset will be the key. The entire line will be the value. So the byte offset is the key and the entire line will be the value. So just to look at how Mapreduce will look at the data. Now we look at data in this particular way, but the way Mapreduce sees the data is something different. The way Mapreduce sees this data is zero comma 1 2 3 6 7 10 11 14 15 17 18 19 20 21 22 25 26 29 30 34 5 6 7 40 41 44 45 48 49 50 and till the very end. So Mapreduce looks at each and everything as key value pair, and of course unfortunately the blocks are ending in this particular fashion. So one block ends here and other block is ending So this is how Mapreduce looks at the data. So a block is illogical 128 MB, but what Mapreduce does based on text input format is it sees data in terms of input splits, and as per that, the input split 1 will look till here, and input split 2 will look till here. So the point here is input split 1 will be the first logical end, and input split 2 will have the second logical end. So the first point to be noted here is blocks are illogical 128 MB, whereas input splits are logical. Second, text input format looks at so from the face value there are 3 blocks of 128, 128 and 44, but the way input split sees is input split starts navigating and it looks like oops, there is something not completing, and it goes till the end. So that becomes your input split 1, and input split starts here and again sees something illogical and reads till the very end. So there'll be basically 2 input splits. So blocks are illogical and input splits are logical. Text input format works towards creating logical splits. So it's the job of input format. So what we mean is input format is basically the workhorse that makes sense out of the data that's illogically broken. So there are many input formats. The default is text input format. Key value format /n is the record end. So these are some input formats. These are some input formats. So the way it works is your data, which is broken, is by input format. By default it's text input format. So text input format would say that this is what is done by the text input format. In this case, this is text input format. So to look at the formats, the default is text input format. You can have key value format. There is sequence file format, and you can write your own format also. So we can write our own format. How does that work? Let's understand. So we say so we can have our own format, and in that format we will have to give implementation for two things. So these are the two implementations that we are supposed to give. What makes one input split, and second is what makes one record. What makes one record? That is what we are supposed to give. So let's look at a quick representation of that. So let's say the data that we get, looks like let's say this is the data that we get from certain sensors. Actually, these are two records. So the first record is for General Motors Chevy, which has a flat tire, and the second record is for Toyota Prius, which is again having a flat tire. But here we don't have a delimiter. So this is a clear case where text input format is not going to work. So we had text input format so far for word count and everything was perfect. But in this particular case, text input format is not going to work for us. We need something more than that. So once you get data like this from the sensor or the company that builds the sensor, you may get a documentation that looks like 40 bytes is each record, 10 bytes is date, another 10 bytes is manufacturer, is the make of the car, and 10 bytes is the event. So there are two things clear. We don't have a delimiter, and text input format is not going to work for us. So here we can create our own format that looks like class auto event file input format extends file input format. In this, we are supposed to implement get input split. Here we are going to say so this is our way of saying that a single input split would be 128 MB plus sealing of logical end, or clearer way would be sealing of 128 MB. What that means is if the block completes at 128 MB and the data is still not logically complete, whatever is trailing in the next block, please read that and create one logical input split. That is how you would go about implementing an input split. And the second implementation we would give is in record reader we would say that exactly have this, and we would return key as, let's say, date, and value as, let's say, event. So this will be our implementation. Now, in our Mapreduce code, what we are going to do is in the driver we will say set file input format is no more text but auto file input format class. That will be our driver. And our mapper, once it gets key and value as input, automatically key will be the date and value will automatically be event. So this is how you get your key value pairs. So when we say that we are going to use auto event file input format, every record would pass through this record reader, and what we get back in the mapper is date and event. We will not be getting manufacturer and model. So our key will be date and our value will be event and nothing else. So this is how we can customize our file input format. This is how we can go ahead and customize our file input format. So what we've seen in input format is they calculate input splits, and they as per text input format, key is byte offset, value is whole line, and /n is the delimiter. If we wish to So this was part 2 of the advanced Mapreduce, where we first, if we really build the whole thing now, the first phase of the course we learned what is Mapreduce, what is mapper, reducer, combiner, partitioner. We learned how to write them. We learned how to design them. Then we spoke about what is a tool runner, that's like customizing the behavior, how to unit test your code, how to use distributed cache, Hdfs API, setup and tear down. And in this part 2, we went one level further, or this could be called as the top level of Mapreduce, where we say that, okay, Mapreduce, you've been doing this in default, but I would like to customize the writables. So instead of, let's say, int or text, we would like to go for date. So we saw how to go about having our own custom writables. For our own custom writables, what we'll have to do is we'll have to implement writable comparable and give the implementation for them. Then we saw that, okay, everything is text, but what if I want to serialize them using sequence files in Avro, and we can compress them. And in the third case, we went ahead and we conveyed Mapreduce that, okay, text input format is default, but what if I would want to have my own format, and we saw how to go about it. So the entire flow is, we've gone through the basics of Mapreduce, we've understood the advanced part where we kind of were externally modifying things, and in this particular video we've gone and said, okay, whatever is default we would like to change it. And we've seen how to change the input formats, we've changed the custom writables, and we've also seen how to go about sequence files in Avro. So this was all about the advanced Mapreduce part.